Hey everyone, welcome back to another math video. In today's video, we're going to be talking about a topic in geometry known as the median. What is a median and what does it have to do with a triangle? Okay, so let's go ahead and let's get started. So what a median is talking about a line that you can draw inside a triangle that goes from one of the points, so let's say point A. It's going to go from point A, from one of the points on a triangle, to the opposite side, but it's going to go to the midpoint on that opposite side. So it's going to connect this corner A to the midpoint of BC. So let's say the midpoint of BC is right here, and I know that's the midpoint, so just to clarify, I'm going to draw the congruency tick mark saying that those two distances are the same. So let's go ahead and let's draw a line connecting these two. Actually, I want to draw it in blue. And this right here is what we call a median. Alright. And we can do this actually, since a triangle has 3 points or 3 sides, we can do 3 medians inside a triangle. So let's go ahead and let's draw the medians for the rest of the sides and the points. So for point B, I would look at the midpoint for side AC, which would be somewhere around right here, meaning that these two segments would be equal to each other. So let's go ahead and let's connect these. There's my second median. My third median would go from the point C to the midpoint of AB, which we'll just say is right here. Let's go ahead and connect those, but first, again, these two segments would be equal to each other. So let's go ahead and let's connect these. Alright, so these are the 3 medians inside this triangle ABC. Now, the point where they intersect, which is right here, also has a special name. This point is known as the centroid. Okay, so when you have medians intersecting, whether it's 2 or 3, the point where they intersect is what we're going to call the centroid. Okay, now the centroid does something very special to each of these lines. The centroid cuts them not in half, but sort of at the 2/3 mark. So it cuts it, and you have one side that's 2/3 of the whole line, and the other side which is 1/3 of the whole line. And some of you are probably looking at that and saying like, ew, I don't like fractions. Well, that's understandable. But here's what that really means. If one of them is 1/3 and the other one is 2/3, that's another way of saying that one of them is twice as long as the other. So, for example, that's like saying it's splitting each of these lines into one piece that's half as small as the other, or into one piece that's twice as long as the other. So for example, let me actually put words so that this makes sense. If the small piece is 4, let me put some numbers, this piece is going to be twice as long as that, which would be 8. Okay? If this piece, let's say they give me the long piece and they say this piece is actually 10, then I know that this small piece is actually half that size, which would be 5. And again, let's say they told me that this piece right here is also 4, then that tells me that this longer piece has to be 8 as well. And this is how we use the centroid to help us solve for certain problems, okay? So now let's go ahead and let's actually put this to work. Let's see an example problem where we might be able to use this. So here it's asking to find the length of each of the medians of this triangle. So I'm going to find the length of each of the medians. Since they're asking for the medians, they actually want to know the distance of that line that goes from one of the points to the midpoint of one of the sides. Okay, so let's start off by looking at one of them first. Let's go ahead and look here at AF. That's a median. How do I know? Because it went from one of the corners to the midpoint of this side, because I can see that this is equal to this. So, I want to know what is the distance of AF. Well, they told me that this smaller line here, this piece of AF is 9. Well, if this is the centroid, which it is because that's where the medians are crossing each other, then I know that this piece has to be twice as much as that shorter piece. So if the short piece is 9, we double 9, we get 18. I know that this longer piece is 18, meaning that AF was going to be 18 plus 9, which equals 27. So we found AF. There's 2 more medians we gotta find. Now let's find BD. So for BD, I know it is 24 plus something. I'm not sure what that other piece is. Not yet. But again, we can see the centroid. We see that the long side of that green line, after it's cut in half, is 24. So all I need to do is cut that 24 in half to find that this small side would be 12. 24 divided by 2 is 12. So then BD is just 24 plus 12, which equals 36. Finally, we can look at CE. So I know that CE is going to be 8 plus something. They gave us the shorter side of CE. So if they give me the short side, double it. If they give me the long side, cut it in half. So 8 doubled would be 16. So 8 plus 16 would just be 24. And I found the length to each of these lines. And this is how we use the definition of medians and centroids to help us solve a few problems in geometry. So hopefully now you feel like you're able to use the definition of a median and a centroid to help find some missing lengths of a median, or maybe to find the length of a part inside a triangle. Okay, you can use these later on when you're working with other pieces of a triangle. Maybe it'll help you with Pythagorean theorem at one point. Okay, the application of using these depends on the problem that you're working with, but hopefully now you can at least use it in a basic sense, and hopefully later on you'll learn how to use it in a more experienced or a much more rigorous problem. Okay, as always, I just want to thank you guys for watching. I hope you continue to learn some math, and I'll see you guys next time.